Hello, my good learners and viewers. Today we're going to tackle something little bit we had been doing earlier. So we are going to do a question under open traverse. So this question had been done a little bit a couple of years ago. So and it has only been repeated 3 times. So we are going to tackle this question and we can see how best we can provide our answers here. So this is a neck survey 2. So this is under traversing. So 2023-2024 match series had this question. So the person who is educating you, certified TVET trainer. This is Gadgira Steven from Matili Technical Institute. Feel free to join the institute. So the intake is ongoing. We are going directly to the question. So the next question paper, those who will be having it available will give you the link. So my screenshot was a little bit blurred. I decided to just write the question on my own so that we can solve the question and have it well represented by what we have being done here. So this question is going to be done in a simple way. Let's go ahead. An open traverse was run from point A to F in order to determine the bearing and distances of line AAP. So that is the thing that we are needed to do. So we are supposed to determine the bearings and the distances of those two. So this line AAP, using the data in the table below, compute the bearing and the distance of AF. So here we have been given a table having 3 columns. So on the first column here we have the line. So that is the pathway of the traverse. We have the bearing of the line and we have the distance covered between those points on the line when doing your traversing. So AB, bearing of 150 30, distance covered 800. So from B to C, 1510, distance covered 900. From CD to 2020, distance covered of 670, that is in meters. DE, we have the same. We have been given the bearings and the distance, and the same is done to the last part. So here we are supposed to find, so we are supposed to determine the bearing and the distance of line AP. So that is the distance covered from. So this is an open traverse. So by joining those two opening, we are going to determine the bearing and the distance of that line. So the line found between A and a point. So this point of, so this is A and not P, this F. So A and F. So the distance covered between A and F. That is what we are going to do. So we go directly to the solution. So here we have our a little bit solution. So the first thing, we convert the bearings to Cartesian form. So the bearings are used to find the components of the traverse line in E. So the eastings are represented by the X axis and the Y represented by the northings. So this is the direction in which we use. So from the Cartesian form in their solution. So using trigonometric function, so the additional, we are supposed to find the change in X and even the change in Y. So here we have a little bit, I'm sure you are familiar with this formula. We use it in Bondwich. So this is what we're going to do. So we are going to calculate these two. So this is the easting and the northing. So this formula, so this is for the easting, this for the northing. We are going to calculate the easting and the northing for all our lines found there. Later on we are going to calculate the same is done. So and then we add so d is the distance. Now by adding the easting and the northing, we'll be able to calculate what we are supposed to do. So the distance covered between a f, so that's the distance and the bearing covered there. So these are the formula that we always use when calculating bondage method. So it's d multiplied by sin theta and also d multiplied by cos theta. So this is the formula for calculating so this is the distance covered. So in the Cartesian plane, so the y and the x axis, so we are supposed to find that distance covered there. So by the use of this formula, we are able to calculate the something like length, which represents the easting and the northing. So remember this formula. I think we have discussed it much earlier on the bondage, even the transit and any other method of calculating traversing there. So this is simple control. So by formation of such control points, we'll be able to get our final answer. So we'll go directly. So d, remember, is the distance covered. Sine, you know where sine is. Cos, you know where it is. The bearing, this is the theta. That is the angle given to us. So we are going to calculate for the easting and for the northing. We go ahead. So on line AB, so we do that. So here, this is the eastings. So here we have the calculation for the easting, and here we have the calculation for the northing. Or in other words, we can say this is the departure and this is the latitude. So all those concepts found on our various calculations found in the traversing. So the departures and the latitudes, eastings and the northings. So the first thing here, we start for line AB. This simple calculation by the use of a calculator correctly, you can be able to do this activity well with no inches. So this is just simple representative. Make sure your calculator is calibrated well, and by doing so, you'll be able to find the final answer more correctly and more better. So we start in the eastings. So this is d times sine theta. We have been given here. So on our AB, we have the bearings here and we have the distances, and also for line BC, also we have the bearing and the distances. So these are the data that we are going to be using in our table, the table that I had just shown you. So the bearing, this is the theta, and the distance, here we have it. So by the use of your correct calculator, pressing well, so we'll find these are the departures and the latitudes, or the eastings and the northings, that we have calculated. So remember, we can have a negative or a positive. That is just the it shows you the direction of the departure and the latitudes. So you can do that to all your answers. So you go ahead. So d multiplied by sine theta, and you get the answer. So you remember on the calculator, we have the here we have the degrees, we have the minutes, and we have the seconds in the calculator. Remember to input those well, so that you can get the. So here we have only those two, the degrees and the minutes. So 150 degrees, 30 minutes. That we are going to sign it and then multiply by the distance. Then on the nothing, we are going to do the same, but here we're going to use cos and multiply by the distance. Yeah, this is just simple. I know to you it is much simple, and something that you can do without any fear of getting your correct answer. After doing that, so by having all this, so by covering the these are the control points from A, B, C, D, E until we have where our F is. So we'll have this. So yeah, I can say we have the latitudes and the departures, the northing and the eastings, or the some representative of coordinates. this will be your representative here, after which you sum up all the components. So you sum up all the components and you get the total. So you'll add all the changes in X here. So you'll add all the departures here. So remember, you observe the signs. Where you have a negative, make sure it's a negative. So you'll add all the departures, you get your total answer. So the value that you get, the total X for the traverse, so that will be the total here. So this is the total value that I have gotten from here. The same will be done. So you add all your changes in Y. So these are the latitudes or the no things representative. You add all of them to get the total. So here also we do have a total. So this is our total here. So we have a total there of negative, remember that. So that is the total here. We have so here we have a total, and also here we have another total. So those are our totals that we have gotten for additional of what we are been doing here, after which those total will enable us to move on to the next thing. So on our next solution, we are going to calculate the resultant distance, that is the distance from A to F, so which is the resultant gotten from the this is the summation of X and the summation of Y, so that is the total. So we start with the distance. So D is equals to the square of summation. So this is summation. So D is equals to square root of addition of the square of summation of X and summation of Y. That means we are going to the value that we have gotten here. So this is what we are discussing. These two, these are the values that we are discussing there. So we are going to do that. So the distance, so D is equals to the square root of again here calculator will be of much help if well calibrated. So remember, here we have a negative. When you square negative, the negative disappears. I think we were taught that on our lower levels, either in primary, yeah, there, or in the lowest. So here we'll have the square root of what we have here. So you'll square first addition of that of those two, then you find the square root, and our D will be 863.1628 meters. So this is the distance covered. So this is the distance of A to F, that is the distance covered between those two there. We move on to the bearing. So the bearing of AF. So the bearing of AF is computed using, so this is another simple formula. I'm sure you are familiar with it. So bearing is equals to tan inverse, so the total summation of X and the over the total summation of Y. So these formulas, we use them somewhere, I'm sure you remember. So we adjust the angle based on the quadrant. So first of all, we do this, the bearing is equals to tan inverse. So this total, the two totals are what we got here, remember. So these are the totals that we are speaking about, the total in the total in latitudes and the total in departures. So those are the things that we are saying we are using here. So the total in latitude and the total in departure. So by having the by dividing those two, and then you find the tan inverse, you'll get negative 79.8155. So you change that into degrees again. So here we have been given, so we have been told to adjust the value based on the quadrant. So I'll look for the value where I'll find where my tan is positive and the nearest quadrant. So we have 4 quadrants, remember. So I'll look for the quadrant where we have a positive tangent, and my quadrant will be in the next. So I'll move on by addition of 2 quadrants. So by adding 180, I'll have gotten a positive quadrant of 100 degrees 11 minutes and 44 seconds. So that is the bearing that we are getting from our solution here. So this is the distance, and here we have the bearing of our question. So that was just a little bit simple, something to be done without any much ado. So for more lessons, remember to subscribe. So when you subscribe, you can get the notifications of any new activity or anything new that I'm doing. So you remember to subscribe to the channel, remember to follow for more. If you have any question, you can ask on the comment, or you can get me through the email. I will freely answer your question and make sure you get the right knowledge to move on and to succeed your career or anything under survey works. Thank you. That will be all for today.